Welcome back to the Deep in State. I'm your host, Nick Hawks. On today's show, we've got Kee Jefferys, co-founder over at 𝐒𝐮. This show is sponsored by Oxen Associates, the most experienced deep in consultancy in this space. If you'd like to learn a little bit more about us, we'll say more later in the show. Before we get started, make sure that you hit the like, subscribe, smash the bell, do all those things that helps us keep bringing great guests like Kee to you. Kee, thanks for coming on, man.
Yeah, nice to be here, Nick.
I'm psyched. I'm always psyched to learn about a new DePIN. For folks who have never seen you before, let's start with you. Kind of who are you and how did you come to be where you are?
Yeah, so my name's Kee. I'm one of the co-founders of 𝐒𝐮. We started actually in 2018, a long time ago.
Okay.
And deployed what was originally, I guess, a masternode network, which is kind of quite close to the idea of, or shares some of the original theology with DePIN networks.
Mm-hmm.
That network has been deployed since 2020. We've been working on that for a while. My background is more on the computer science side, so more of the kind of technical co-founder in the business. And yeah, really excited to talk about 𝐒𝐮 and what we're doing here.
Okay, cool. And you've got two co-founders, Maxim and Simon. Sounds like there's like a badass threesome there. Kee, Maxim, and Simon. Like you got cool names.
I wish it was a threesome, but it's actually a foursome.
Foursome. Okay, there's four. Yeah, there's only three on the white paper, and then the white paper just came out in 2024. So it's good to know that you guys started way back in 2018, and now you're seeing like, okay, cool. This is how we think we're going to do this. Is this DePIN method? Is that right?
Well, actually, the white paper has kind of been iterated over time. So we did publish a white paper in 2018.
Okay.
But it's been kind of updated over time as the network has changed. I think we're on like version 3 or 4 at this point. We try to keep it fairly up to date with how the network actually looks. That's difficult. I've spent a lot of time writing white papers, but yeah, it's a good idea to give people a technical overview of the network.
Yeah. Well, speaking of, that's a nice segue. What is 𝐒𝐮? What does it do? Walk me through it.
Yeah, so 𝐒𝐮 is a private end-to-end encrypted messaging application. The things that it's focused on over other messaging applications like Signal or Telegram or WhatsApp is kind of 3 things. First off, we don't require a phone number to sign up, so that removes private data about yourself. We use an onion routing network to hide your IP address when you use the messaging application. And we use a fully decentralized structure for the storage and routing of data. So we don't have central servers like Telegram or WhatsApp or Signal. You're actually storing and routing your messages when you use 𝐒𝐮 on a decentralized network of 2,100 nodes. And that is the DePIN network and how it's involved in 𝐒𝐮 itself. Growth has been really good thus far. Like we have 1.2 million monthly active users on 𝐒𝐮 and get lots of downloads per month coming into the application. So it's one of the more used DePIN networks, because obviously that's something that DePIN networks kind of can struggle with, is like you build the supply side of the network, then you also need the demand side to come in and actually use the network. That hasn't been so much of a problem for us. And yeah, 𝐒𝐮's just really focused on delivering a product to users that they can use backed by that DePIN network.
Got it. Okay. So a couple questions there. There's 2,100 nodes on there. I'm assuming those nodes are run by normal people. It's not like a bunch of data center nerds are running those. Someone like me might be running on a Raspberry Pi, something like that. Or do you need something more powerful?
Yeah, so the operators are people from all around the world. There's no like KYC process or anything like that to start running a node. You just need a certain amount of stake.
Okay.
And then you run a piece of software and you stake that those tokens with that software. And then you start running like a storage server, which stores other people's encrypted messages, and then a routing service, which will route those around. In terms of like the hardware that you can run it on, the hardware is like, we don't have really high spec hardware, or we don't require really high spec hardware, because really what you're doing is storing very small messages and then routing data between nodes. So that's not actually a very heavy operation compared to some of the other DePIN networks where you're doing a bunch of compute or other kind of higher tier services. So most people in the network will run their node on a VPS, but you can run it on a Raspberry Pi, you can run it on a home computer. The main thing is that the network that you're connected to is very stable, and that node doesn't go up and down over time, that it's kind of consistently available on the network. And the network kind of self-polices itself to determine whether nodes are online or offline, and how they're providing service to the network as well.
Got it. And then walk me through the token side of this. I mean, yeah, I've got a bunch of questions on that, but walk me through the basics of where it is, where it's going, and maybe where it started.
Yeah, so I mean, where it started was in 2018, and originally the idea was that because we're obviously interested in building privacy technology, that we were also going to build a privacy token, and that launched as 𝐒𝐤𝐞𝐚𝐰𝐚 or Oxen in 2018,
Mm-hmm.
and we've been continuing that vision up until today. I think the privacy token had a lot of headwinds to it because obviously regulators and exchanges and stuff have issues with privacy tokens. So recently, we've decided that we are going to fork, or not fork, but migrate from the Oxen token to the session token. And session token is just an ERC20 token. And that is something that the TGE is coming out for the session token, but has not yet been launched. So there's an existing network which is running on the back of Oxen, which is privacy coin. It's a fork of Monero, has all of these interesting kind of properties to it. But we are kind of migrating from that Oxen coin to session token. And just to describe like the token economics a little bit as well, essentially you need the token to stake a node into the network.
Mm-hmm.
So that creates a demand from stakers to be able to get the token, and then they earn token rewards for providing services to the network. So that's routing people's messages, storing people's message data, and also like they run this onion routing network as well. They get rewarded in session tokens or Oxen for doing that, and then there's also like kind of natural sinks which are created through the applications which are built on top of the network itself. So if you think about something like the session messaging application, I think the idea there from the session team is that they will build in something very similar to Telegram Premium, where it's kind of a subscription service for $4.99 a month, and that provides particular premium features like in Telegram, if a larger file uploads, more customizability in your profiles, and then that kind of payment from users, is converted into session token, makes back to the network, and converted into Oxen token. So you have kind of the supply side, which is provided by the nodes, and that they're being paid out for the services, and then you also have the demand side, which is coming from the applications which are built on top of the network.
Cool, and it's being used, which is always a good thing with DePINs. Okay. Let's take a quick break, and we'll talk about today's sponsor, Gold Hawks and Associates. We're a DePIN consultant firm helping projects with strategy, messaging, and token incentives. We run a blog for founders over at goldandhawks.com, produce this show, and most importantly, work with the core teams and communities of your favorite projects in the space to ensure tokenomics and incentives are fully aligned to build out some of the most badass physical infrastructure networks in the world. If your project needs help with any of these, check out goldandhawks.com. Okay, Kee, so walk me through then, if I'm going to participate in this thing and I want to bring in a node, are there ways for me to earn more or less? Can I bring in some mega, multi GPU? I can't see how that would be helpful, but some like giant, super stable node and earn way more than a normal person? Or is there not really an incentive to have like a super exceptionally good node? It just has to be stable.
Yeah, there's no tiers of node in like Oxen or session token as it will be. So that's not how it exists right now. It's something that we have thought of before, particularly in the realm of file storage, for example, because when you're storing files, I mean, we like the session application supports files up to 10 megabytes right now, which is like small compared to like say Telegram and WhatsApp. But compare that to the size of your average like text message, which is probably like around a kilobyte.
Yeah,
and you're looking at like up to 10,000 times larger. So it is a different tier of storage. Right now we don't do that, but I think it could be something to explore in the future. But yeah, I think it's not our current focus. We always thought it would be that kind of simpler to explain to people if you just have the single tier of nodes and every node does performs a similar function, and then you just like enforce those nodes being like of a particular level of service. So that's what we've done thus far.
Got it. And really the enforcement is around the stability of the connection. Is that right?
So there's 5 or 6 things that service nodes will test other service nodes for, and then they kind of vote in these quorums to deregister other nodes if they're not doing well. So, I mean, we have the basic things like uptime proofs, which is basically like your node sends a ping into the network saying, hey, I'm alive. But they will also more actively test whether those nodes are reachable for particular services. So, for example, we have the storage server, which is what session clients will use to store messages. The service nodes also test each other's storage servers to see if they can store messages there or if they can reach those service nodes via that storage server. And they do the same thing for some of the routing tools that we use internally. So they're testing on multiple metrics, and then they kind of come to a local understanding, and then every now and then they vote on that local understanding to determine whether a node should be on or off the network.
Okay, cool. Super cool. Let's see. So say you're down at your local meat pie store and you're explaining this to someone that you run into. I think one of the questions they would ask is how do, I'm storing all my messages on someone else's, whatever, VPS, Raspberry Pi, whatever it is. Like, how do I know those things are secure?
Yeah. I mean, that was one of our concerns when building the protocol as well. The simple answer is, or I think there's kind of two answers to it. First, everything is end-to-end encrypted. So the nodes themselves don't actually see the underlying content of the data because it's end-to-end encrypted. So it's encrypted for the other person. It's not encrypted for the server. So they're just kind of passing on encrypted blobs.
Okay.
And the other thing is we strip all of the metadata, or a lot of the metadata, from messages when they get sent to the network. So as I was talking about before with the onion routing network, that hides your IP address when you store a message on a particular storage server. So that's removing some metadata. We don't require a phone number, for example, when you sign up to session. So when you send a message, it's not attached to a real world identifier, it's attached to a public private key pair. So, and there's kind of blinding around messages as well to hide that, even that key pair, that anonymized key pair. So from that perspective, like, we're focused on encryption and removing metadata. And then there's another aspect, which is if you're in that network of 2100 nodes, not every node stores every message. So basically what we do is like we shard the network into a bunch of different, like, smaller networks, big enough to keep redundancy over the data, but small enough so that not all of the data that you send on the network is being shared with everyone. It's only being shared with a subset of like 7 out of, typically 5 to 7 out of the 2100 nodes. So now if you join the network, if you want to target a particular user, it's really hard to join a particular swarm to get that user's data because there's 2100 nodes and you're randomly sorted into those swarms. So yeah, that's kind of, I think I said 2 things. That's almost 3 things, I think. But we're very focused on that side of things as well to remove that metadata.
Okay. And then you said it goes through onion routing. How many hops is that? Is that 3, 5, 7, 19? What does that look like?
It's 3 right now.
Okay. Seems to be the standard in these things.
Yeah. I mean, like, I think Tor really set the standard in terms of onion routing protocols. So we've built our own, and it just uses 3. You could go less, you could go more. I think on the more side, you start getting into like, higher latency, and that starts impacting the user experience of the messaging application.
Yep.
And on the less side, obviously, you start to run into more kind of security concerns.
Yeah.
Not breaking up the information so much.
And then what's the latency like if I'm going back and forth and yelling at someone on the internet or someone on the other side? Are we able to do that in real time, or is there a pretty big delay?
So I think the way that we've implemented onion requests, we call our onion routing layer onion requests right now, is quite naive. Like, we kind of, when we launched the network, we're like, okay, let's build out this onion routing network. We'll build this like really simple protocol, which is based on TCP and doesn't have any of the advanced optimizations that we have in some of our other onion routing protocols. And we'll deploy it. And we thought, we'll fix it up. Like, we'll iterate on this like really quickly.
We'll get to this later. Yeah.
Basically. It turns out it's like much harder to build a massive, like, scalable onion routing network than we initially thought, and we're building it from the ground up as well. So that protocol is called 𝐒𝐤𝐤𝐞𝐚𝐰𝐚𝐤𝐿 is called onion requests. Onion requests, the latency is probably around 1.5 seconds to send a message, which, I mean, it's okay, but I
Yeah.
think if you're looking at, say, Telegram, Signal, like you're looking at like 100 milliseconds or 50 milliseconds, depending on where you are and where their server is located.
Yep.
So there's a massive improvement to be made there. With LoCANnet, because of some of the advancements we've made in the onion routing technology, we have gotten the latency way further down. And, we're seeing latency times of around 500 milliseconds there. So, or like two to 500 milliseconds there. So,
Okay. So
getting
better
much
than it was.
closer, to what we want to achieve. And then there's stuff that you can do at the UI level. If the network is really reliable and you can say that a message is always going to be delivered, or 99% of the time network's going to deliver that message, you can kind of show to a user that the message is sent and then send it in the background. And that allows you to get around some of that perceived sense of slowness in the application.
Okay. I got 2 more questions. Is how do I get found? Do people just look up Nick Hawks and there I am? That's the first one. If I don't have a phone number.
Yeah.
Start that.
So you, by default, when you join session, you get a public key, which is, I think 66 characters, something like that. So you can share that with other people.
Super easy to memorize. Yeah.
As a QR code, as well. So
Okay.
it's similar to like a Bitcoin or Ethereum address to
Yep.
send to people. Then they can use that to send messages to you.
Okay.
We also have a system very similar to, say, ENS, where you can map that public-private key pair to human-readable names. So on ENS, I can own key.eth, and then people can message that, and that maps to my key. So we call that system ONS, and that allows you to map kind of that public key to a human-readable name, and that costs a little bit of you have to do an on-chain payment to make that mapping occur. It ends up on the blockchain.
Easy. And then how do you stop spam? I think this was something I'm seeing on Telegrams. I'm starting to get more and more. God knows who these people are. It's like, hey, I'd love to talk. It's like, no, I don't want to talk. How do you stop spam on session?
Yeah, spam is really difficult to stop in a system like this, especially when you don't require a user to have a phone number to set up. Our focus has been on how do we prevent this at the UI level? So, for example, like when someone messages you on session, it goes into a different folder called message requests, which you have to manually accept users through that folder. So it's kind of like the friend request system or something like that on Facebook, where you accept and then you can start messaging that person, but they all just go into a different folder. So you don't have to see it. You don't have to worry about spammers like that. But there's also other systems which we employ, mostly around the discovery of users in the application. There's no kind of central repository where you can discover everyone's session IDs. And when you interact in communities as well, which is kind of the larger groups that we have access to, where it's 1,000 people plus, you use this thing called a blinded ID, which is not your real session ID. It's a mapping of your session ID to an ephemeral key. So if someone gets your blinded key, they can message that. But as soon as you leave the server, you can drop that blinded key and basically their messages get black holed. So there's a few systems that we've built around the side. I wouldn't say what we have right now is perfect. We still need to work on it more. But I think we have a pretty good solution right now for our level of scale. What typically happens with these messaging applications is as they grow, the spam problem becomes larger, and you need to address it at those states. But when you're kind of on the smaller end, we have 1.2 million monthly active users, and Telegram has nearly 1 billion monthly active users.
You can kick this can down the road a little bit.
Yeah, the scale of the problem is a little bit different.
Cool. Super cool. Keith, thanks so much for coming on and taking the time. For folks who want to know more, I think it's getsession.org. Is there anywhere else that they should go to find out more about what you guys are doing?
We're on Twitter. I'm also on Session. So my name's Kee Jeff on Session if you want to send me a message. I'm also on Twitter. We just announced the creation of our Swiss Foundation as well. So that's just Session Technology Foundation if you want to look up the organization that's kind of stewarding the project. Lots to do, and all of our clients are open source as well. So if you want to contribute to the network and what we're building, that's all available there too. Look forward to seeing you on the network.
Right on. Thanks so much for coming on and taking the time to explain it. Appreciate it.
Thanks, Nick.